All right, so if you're following along from the last question, this one's going to be similar. In the last one, we used the product rule and the chain rule. So now this one, we're going to have to use the quotient rule and the chain rule, because you can see, yeah, we've got a function over some other function, but we're just going to have to use the chain rule in this bottom version, right? Okay, so let's do what we did in the last one. So if we call the top function, we'll call this f, and we'll call the bottom g. Okay, so now let's just write everything out that we have. So f, I'm just writing this again. We've got 9x cubed plus 2x. All right, so then f prime. So we don't need to use the chain rule for this one. This is just taking the derivative of these individual terms. So bringing the 3 down, this would become 27, right? 3 times 9, x to the power of 2, and then plus 2. All right, so there's f and f prime. So now let's do g. So g is 6x plus 1 to the power of 3. And then g prime. So now we are going to have to do the derivative, or the chain rule here. So if we do the derivative of the outside function first, 3 times 6x plus 1, and then to the power of 2. Okay, so that's the derivative of the outside function. And then don't forget, we have to multiply that by the derivative of the inside function. So the inside function here is 6x plus 1. So that would be just 6 for the derivative. Just writing it a little different. I'm just going to multiply the 3 and the 6. So now we have 18 times 6x plus 1 squared. Okay, so we have everything we need to just kind of throw this into the quotient rule now. So let's write down the quotient rule. So the quotient rule, so here I'll say y, we'll say y prime. So y prime is going to be g minus f prime minus f g prime all over g squared. All right, so now let's just fill it in with what we know. So y prime is. So our g was 6x plus 1 cubed, and then times f prime, and our f prime was 27x squared plus 2 minus, and then f was 9x cubed plus 2x. Notice that I put this in brackets, right? Because the subtraction can mess things up, right? If I didn't, then it would look like I was only subtracting 9x cubed, but it needs to be in brackets because I'm subtracting all of this in the end, right? So, all right. And then last one, so now I just need to do my g prime. So g prime here was 18 times 6x plus 1 squared. And then this is all over g squared. So our g was, not g, our g was 6x plus 1 to the power of 3. But then it's squared, right? So this is all to the power of 2. Which, on the next step, it won't be so bad, right? Because really, we just got a power to a power. We're just going to multiply those guys. All right, so what's the idea here? Well, on these ones, typically what we want to do is we want to cancel something on the bottom, like as much as we can, right? You see, we got this 6x plus 1 on the bottom. And it's really 6x plus 1. I haven't wrote it yet. I will on the next line. But it's 6x plus 1 to the power of 6. So I want to cancel as many of those as I can. Do you see any 6x plus 1s up in the numerator? Yes, there are, right? There's like 2 over here, and there's 3 over here. So what I'd like to do, I'd actually like to factor out 6x plus 1 out of this term over here and out of this term over here. Okay, so that's what we're going to do next. Let's just, hopefully we see this. So this here, that's one of my 6x plus 1s, and then this one as well. Okay, so like I said, let's factor that out now. So just up in the numerator, what I'm thinking here now is 6x plus 1. And how many can I factor out? Well, like I said, there's 2 over here and there's 3 over here. So I have to take the smallest exponent on this, right? I need the greatest common factor. So this is 2, right? I get take out 2 of those. And then that's pretty much it. There's nothing else in common with this term and with this giant term over here. So I'm just going to start my square bracket and then write what's left. So now I'm going to go back through, and I can see I've still got 6x plus 1 here. So we've got 6x plus 1. And then I've still got my 27x squared plus 2 minus, and now I've still got this one as well. I've still got my 9x to the 3 plus 2x. And then, well, this one is now gone, the 6x plus 1 squared, because we factored out that entire piece. So why don't we, instead, this might be a little annoying, but typically you write the number out front. So I'm going to say minus 18 like this, right? It could have been on the end. I could have went this times 18, but typically we just write our coefficient out front. Okay, and then that's it. Okay, so it's not quite it. So now we still need to write this over the same denominator. So we've got 6x plus 1 to the power of, and as I said before, this is, to the power of 3 to the power of 2. We multiply those. So it's all to the power of 6. And then this will get a little simpler because you can see now that this 6x plus 1 squared up in the top, that gets to cancel with 2 of them in the bottom as well. So this now becomes to the power of 4 in the bottom there. So now my numerator gets a little simpler. So now we just have 6x plus 1 times 27x squared plus 2 minus 18, and then 9x to the 3 plus 2x, and then now that's all over 6x plus 1 to the power of 4. All right, so now what's left to do is just expand this all out and collect any like terms. That's all we can do here now because there's nothing in common with this term and with this term. So yeah, so now let's expand this out. So y prime is, so we're going to FOIL this guy. So now in that case we get 6 times 27, so we get 162 x to the 3 plus 12x plus 27x squared plus 2. That was just expanding that guy out. And now minus, actually you can do this 2 ways, right? I can say minus and then I could expand those in, or you could think of this as like negative 18 and expand those in, right? It'd be the same thing. So we've been doing that for a while. I'm going to assume it's negative 18 and put it in. So then we end up with negative 162 x cubed and then minus 36 x. And then this is all over 6x plus 1 to the power of 4. Now you might have noticed something. I've got 162x cubed and 162x cubed, right? But this one's minus, so these two guys cancel each other out. So that worked out. And then we're pretty much done. We're almost there. So then y prime is equal to, and I'm just going to collect any like terms that I have. So we end up with oh, sorry guys, you probably saw this. This should have been 27, right? I wrote 2. I don't know if I said 7. But yeah, 27. That was just from that middle term there, right? Okay. So then now we have 27x squared minus 24x. That was just collecting our like terms here, right? Ended up being negative 24x plus 2 all over 6x plus 1 to the power of 4. All right, so now this is a perfectly legitimate way to leave it, right? If you could factor the top, you might want to factor it, especially if there's a chance that it could cancel with one of the factors in the bottom. But for the most part, you wouldn't want to expand this. That would take forever. This is actually a great way to leave it anyway. And yeah, so this is a great way to leave your final answer. But there is more than one way to leave your final answer, which can be kind of frustrating for students sometimes, right? Where you're like, what is the answer? Well, there is no like the answer. There's just kind of like better and worse ways to leave it. And this is a pretty simplified version.